Hi, everybody, and welcome to today's Alluxio webinar. We are super excited for you all to join us. My name is Ali, and I will be your moderator. So before we get started, just a few housekeeping items to make sure everybody's aware of. First of which is that all participants are automatically on mute throughout the participation. If you have any questions or wish to communicate directly with me, you can do that by selecting questions from the GoToWebinar control panel, which is located on the right-hand side of your screen. All you do is just type a message or question. I'll be able to see it, and I will be monitoring this throughout the presentation. Second, we do have some time allotted at the end of the webinar to go through your questions. So feel free to, at any point during the webinar, enter a question into that box, and we will make sure to address it at the end of the webinar. Last, today's webinar is being recorded and will be available for on-demand playback from our website. We'll also email you a link to the slides as well, so you can look forward to receiving both of those things. So with that, I am super excited to introduce our two speakers. We have Bin Fan and Calvin Gia, two of our founding engineers, and they will be talking about our brand new release, Alluxio 2.0 preview. Super exciting things to share from them. Before we get started, I'm going to actually put up a poll. What is your experience with Alluxio? So if I can give everybody just a minute or two to give us some feedback, tell me where you are in your Alluxio journey. Give everybody another few seconds. It looks like most people are hitting their buttons. Great. Closing the poll, sharing the results so you can see. Awesome, we have a good mix of folks, everybody from just learning about Alluxio to trying it out to using, so that's awesome. So with that, Bin, I will pass it over to you. Let's get it started.
Thanks, Alex. So today I'm here to introduce Alluxio 2.0 preview, and I'm going to speak about Alluxio 1.x, all the good things about 1.x, what we learned, and then I will translate my speech to Calvin, who is the release manager for 2.0, and he has a lot to talk about cool new features in 2.0 we're building. So this is about us. I will leave Calvin to introduce himself a little bit. Maybe.
Yeah. Hey guys, I'm Calvin. I'm the release manager for Alluxio 2.0. As you guys maybe know, Alluxio 2.0 preview was recently released maybe a few weeks ago, but we still have the GA release coming up in about 3 months. And I've been contributing to the project since the early Tachyon days in 2012. And I'm currently a founding engineer at Alluxio Inc.
Thanks, Calvin. I'm Bin. I'm also the founding engineer, one of the founding engineers in Alluxio, and working from early days with Calvin and also the founder Haoyan Li on the project. I'm currently the Alluxio PMC maintainer for the open source project, and also engage a lot with the community in terms of helping users and understand their use cases. So I want to talk about, this is the agenda today. We first of all talk about the Alluxio overview, and followed by the motivation why we want to build Alluxio 2.0, and with the architectural innovations to enable all the cool new features in 2.0. And then Calvin will talk about the release roadmap too, when we can get the GA release for 2.0. Now let's talk about the overview. So this is a stack we often see, we often show to users about where Alluxio is in the big data stack. So you can see Alluxio serves as the layer between computation, which is to the north or in the upper part, and in the south to the storage part. Because Alluxio has different, we have different APIs. We try to provide the best experience for different applications. So all this computation, they can leverage Alluxio as the open source distributed storage system as the abstraction for data in many different ways. For example, they can use HDFS interface if it's Spark or MapReduce or, for example, Presto applications. Or you can use POSIX interface to interact with the data stored in Alluxio if this is a legacy workloads or the trendy new machine learning frameworks like Caffe or TensorFlow. So Alluxio in the current release in 2.x world is commonly used for data analytics such as OLAP on Hadoop as different ways to unify the data access or to speed up the performance retrieving data, and has been deployed at many different companies, including internet companies like Yahoo or financial sectors like Two Sigma and Tencent and many other companies. And we see the largest deployment is over 1,000 nodes. This gives a little bit overview for the unified namespace, and user can use Alluxio to unify different storage systems. In the example we show here, imagine a user has an S3 bucket and also a HDFS deployment. So in order for the user to provide the logic view to the data stored in different systems, this user can mount the HDFS into the Alluxio namespace, but also mount S3 bucket into a different directory inside this namespace. From user's perspective, what they see is the middle part, the blue trees, and this represents a logic file system emerged from two different storage systems. In this way, application developers or data analysts, they don't need to really worry about where the data is, the physical location for the data, or the library to connect to the data, or even the configuration of security to this data. But Alluxio will handle this, will do the dirty work for you. Next part for Alluxio existing features includes a variety of APIs to enable data access by different applications. For example, for the same file, for the same data, one can use a Spark to read this using the HDFS API. So by default, Spark will understand the HDFS API, and Alluxio provides a HDFS compatible client. So Spark can just directly change their URL from HDFS / to Alluxio / and to get data. And this will also respect data locality to maximize the performance. And similarly, Hadoop client side, Hadoop command line can also can talk to Alluxio directly because Alluxio uses the HDFS API. So if you are used to use Hadoop command line, like Hadoop FS, and you can still interact with Alluxio in the same way. In addition to HDFS API, we provide also POSIX-like API to facilitate AI workloads or legacy workload tools like a Linux shell. In my example here, you can run the Linux command cat to access a mounted Alluxio service into your local directory, and then you can just access Alluxio storage service as accessing the data on your local machine. In the end, we also provide a very flexible, very powerful client, our native Java client, which is similar to the Java file system client. And within using this API, this kind, you can do a lot of fine-grained granularity control into the data and interact with Alluxio file system with a rich semantics. Now, let's talk about different ways to deploy Alluxio nowadays. A common way we see is to put Alluxio and application into the same container or same instance. In this way, we can maximize the chance to leverage data locality for the applications. So in case they see data on the local Alluxio machine, and they will not go to remote Alluxio worker or even the remote storage to fetch data, but leverage local Alluxio storage to get data from at memory speed locally. And this is how we can maximize the local data locality to perform well. And in addition to performance, we also see other approaches people are deploying Alluxio. For example, in some elastic computing environment, we do see people have short-lived computation service like Spark or Presto, and these computation jobs, they come and go, but they can share the common data. And in this way, we do see users deploy Alluxio in a dedicated service, a standalone Alluxio way to deploy the service. And in this case, even your Spark job was there for a while, But once the data is shared, if the input or output data can be shared with some other service like Presto, and they can still leverage by having the data stored in Alluxio rather than always go back to save and retrieve data from the storage.
Great, Ben, thanks. So another quick poll. To what extent is your compute separate from storage today in your environment? I'll give everybody a few seconds here to lock in their votes. Okay, we have a few coming in. I'll give everybody a few more seconds here. Okay. Awesome, and just to share those results quickly, it looks like, again, we have a good mix of half separated, fully separated. Great. Thanks a ton, Ben. I'll let you continue.
So now let's talk about the reference architecture. In the case, for example, we use Alluxio co-located with application. So I'm just zooming into this architecture and show you how typically the workflow is in this kind of situation deployment. And you can see from this figure, we do have Alluxio worker co-located with some application, in this case, Presto and Spark, in two different machines. Right? And in this case, because data is worker is co-located with applications, and it's possible that these applications can leverage the local data stored in Alluxio worker without retrieving data from network. And in this figure, we also show Alluxio masters. We see the Alluxio master and also standby masters. And in this case, Alluxio masters are used to provide metadata service. It's a similar concept to Hadoop HDFS name nodes. Because we want to provide high availability to our users, it's possible you can run multiple masters and use external service like Zookeeper to coordinate the active master. Or in the 2.0, which Calvin was talking about, we also provide a built-in Raft implementation to provide the coordination, so you don't need to depend on external service like Zookeeper. So on the right-hand side, it's that's a really unique concept within Alluxio, which is called Store. And that's basically the source of truth for the data you stored. Remember, Alluxio is not aimed to provide data persistency. Instead, Alluxio aims to leverage Store to have your data, all your bytes stored safely and reliably. And the mission for Alluxio is to best facilitate the computation so we can bring the bytes closer to a compute, but also do a lot of smart, intelligent data management within Alluxio space to help workloads to leverage data better. Okay, so the Store is connected to both Alluxio workers so that they can retrieve data from the Store or push data from Alluxio space to Store. That's the overall reference architecture for Alluxio. Given we have the two layers, Alluxio space and also Store, we enable different ways, a great flexibility to read and write data with many different flag options. For example, if you read data from Alluxio, transparently, if this is data not stored in Alluxio yet, Alluxio will do the fetch for you and make it a copy into Alluxio space. So next time, because we try to leverage, we try to maximize for data locality, we really want to make sure that the applications can benefit from having the co-located data node and reading data from that Alluxio node. And in case application now is running on a different Alluxio node on the second read, you can also still read from a different Alluxio, the original Alluxio worker node to get data. So essentially the reading data path is very is transparent to the users, and we really want to make sure the next or consequent reads can benefit from previous read pattern. And also there are a lot of different ways to configure writes, depends on the applications. For example, if this is a temporary data or this is some data you think you really want to make sure it's written really fast, then they can use the flag to tell Alluxio applications and write this data only into Alluxio space. And similarly, you can set the flag to write data only into underscore. And you can set writing to both synchronously or asynchronously as we introduce a new job service in 2.0, so we can do this really fast and reliable in 2.0. Calvin will mention about this. And you can also do replication to decide, okay, this is the data I want to have in different replicas in different Alluxio workers, so my data can tolerate n-1, no failures. And also you can tell Alluxio to, okay, I want to asynchronously write this data to multiple different underscores, so I can have my data persistency mirrored across different systems, like one in S3, one in HDFS, and another in Azure Blob Store. So far I concluded a lot about the features we can do in Alluxio 1.x world. So all these features combined already enable us a great variety of different applications. Here I will show two typical use cases for Alluxio. One is to burst the workload into the cloud, and this is practiced by the hedge fund 2 Sigma to enable their elastic model training leveraging public clouds. So they have their data training input data in their on-premise HDFS. But in order to get elastic model training, they want to leverage the public cloud to launch EC2 machines to scale hundreds of machines or sometimes tens of machines. It's very elastic. And conventional approach doing this is let Spark reading from HDFS directly, and this can be very inefficient because this is machine learning process can read data in many iterations, but also transfer the same data repeatedly over the while, but going to different machines can be very inefficient. So with Alluxio deployed close to Spark and having data preloaded into Alluxio, and this can greatly speed up the model training process seen by the Spark applications, and also simplify the life for the ETL process for a lot of data scientists. And they see a 10 to 30x performance gain by having Alluxio in this stack. And we actually just had a meetup talking about this use case 3 days ago in New York City in the link. If you want to have more details for that, please check out the link. There is another typical use case we see for ETL elimination by using Alluxio unified namespace provided in 1.x, because we can have multiple different storages, and this can be due to the reason for a lot of legacy departments or acquisitions. So one of the top telecom in US have this situation, have this problem, this challenge. So they have to do ETL for data to move data from one cluster to another cluster to enable their machine learning workloads. And to make it worse, the different data centers are running even on same HDFS, but by different vendors and can be in different versions. And this makes the ETL work even harder. So with Alluxio, because we can hide the difference, we provide different drivers talking to even different versions of the HDFS. And this difference is completely hidden from the users. So the ETL process is no longer needed. The machine learning process just need to access Alluxio to fetch the data, and this can be from the remote HDFS or from a local HDFS, but this is totally transparent. And because we cache data, manage the data intelligently inside Alluxio space, the machine learning process performance is getting also much better. And so this is basically a very good use case to show the benefits of having a unified data access layer to eliminate the needs for data ETL. So these are the two great examples for typical use cases for Alluxio 1.x. But now I'm transiting to Calvin, talk about why we still need a whole new upgrade to Alluxio, and talking about all the exciting new use cases 2.0 can enable.
All right, thanks Ben for the overview of Alluxio 1.x. I think that will be very helpful to give you guys the general context of really what's the major shift between Alluxio 1 and Alluxio 2. So let's start with the motivations of why do we want a 2.0 instead of something like a 1.9, 1.10, and so on. So The main motivation we had was the use cases that Ben was talking about. All of those are nearing the stage of maturity. So we see that the use cases we want to address in Alluxio 1 are becoming pretty well polished. The features that we're adding for improving those use cases are more incremental, some optimizations. But that's not to say the people using Alluxio were completely satisfied with the system. No, the opposite actually. They had lots of large requests that we just figured we couldn't actually put into Alluxio 1 because it would require a complete re-architecture of the system. And these types of requests came in 3 different dimensions. The first dimension was people wanted POSIX-based workloads. Alluxio 1 really worked well with the Hadoop-based API, but with the rise of the new machine learning workloads, a lot of users wanted just direct local file system POSIX interface. Another dimension people wanted to see improvements in Alluxio were better options for managing the data in Alluxio. In Alluxio 1, we provide a few management features like TTL, but they wanted a lot more and a lot more flexibility in defining how their data was managed. And finally, users actually just wanted to scale out more. So Alluxio 1.x has the largest deployment of about over 1,000 nodes, but users wanted to scale to much larger than that, up to like 4,000 or 5,000 nodes. So let's talk about kind of the use cases of Alluxio. I said earlier in the previous slide that we had kind of neared the maturity period for the Alluxio 1 use cases. So in Alluxio 1, these are some typical use cases that Ben had already gone over, but it mostly focuses around enabling cloud object storages and accelerating OLAP on Hadoop systems. In Alluxio 2, we still aim to solve those problems, but we kind of expand the scope to 2 new areas. The first being these new machine learning and deep learning frameworks, specifically on object stores. Users are finding in order to fuel these training models, it's actually best to just add more data as opposed to trying to refine their models. Of course, both are good. And the second thing that we want to focus on in Alluxio 2 is the idea of being able to manage the data lifecycle within Alluxio. So you can think of things like a user may want to automatically move data from their warmer HDFS into a colder S3 and into an even colder Glacier through Alluxio. Okay, so let's talk about the machine learning and deep learning workloads first. The way that we plan to tackle this in Alluxio 2, we mainly focus on the machine learning frameworks. So there's quite a few popular ones out there now, some of them being TensorFlow or like Caffe. So the primary challenge here is these frameworks are used to using a local file system, so a POSIX API, which is quite different from what API Alluxio is used to serving. So we needed to update and improve our POSIX interface so that it could tackle these new challenges, such as the different file access patterns, as well as different file sizes. And working with these machine learning frameworks is a pretty natural fit for Alluxio, though, because a lot of the data that they want to access is already served by Alluxio just through the Hadoop API. So about data management, kind of what we mean by this category is to have a finer control over how data is placed in Alluxio, as well as how data is moved between the different understorages. So this includes features like being able to set minimum and maximum replication factors for Alluxio, to be able to automatically asynchronously persist data and in a scalable way. In Alluxio 1, we provide the async persist feature, but that's a largely limited feature, and even then, a lot of users liked using it. So in Alluxio 2, we aim to make that kind of a truly distributed async persist. A similar idea for data loading, which you can think about as the opposite of async persist. And the last dimension is really around scaling. So we kind of put some, I guess, large numbers here to to target in order to support some of the larger scales that we saw our users getting to. So for the namespace, we wanted to scale to 1 billion files. For the number of nodes in a cluster, we wanted to be able to scale out to 3,000 worker nodes. And in terms of kind of concurrent clients using the Alluxio system, we wanted to scale out to 30,000 concurrent clients. Yeah, so I guess all of those things I talked about probably sound cool and awesome, but how do we really get there? So this section will go over kind of the architectural innovations that really enable Alluxio 2 to solve some of those problems we mentioned. So I'm going to go over a few of the features that are in 2.0, and these are all in 2.0 preview as well. So that's actually something you would be able to download and try out even today from our website. So the first is we moved the metadata storage to off heap. So this enables us to scale the namespace. Currently in Alluxio 1, the namespace can support about on the order of hundreds of millions of files. But with off heap storage, we should be able to scale to billions of files. Secondly, we switched the internal transport layer from Netty and Thrift to gRPC. This enables us to scale to a larger number of clients and worker nodes. Third, we vastly improved the POSIX API. This is primarily to support those machine learning workloads we mentioned. Fourth, we have a new set of daemons in Alluxio. In addition to the Alluxio workers and masters, we now have a job service. And this is in charge of doing a lot of the heavy lifting in order to make data management work. And finally, this is something been mentioned earlier, we have an embedded journal and internal leader election algorithm, which allows Alluxio to be fault tolerant without dependence on external systems. So let's talk about each of these in more detail. For off-heap metadata storage, the way it works is we use an embedded RocksDB instance to store our inode tree, which previously was stored on heap. Of course, using disk storage makes accesses much slower, so this made our RPC latencies go up quite a bit. In order to address that, we added an internal cache for the frequently used inodes, and now as long as your working set of files can fit comfortably within the cache, which can range anywhere from 10 million to 100 million inodes, the performance is pretty much the same as the on-heap option. For the gRPC transport layer, we switched from Thrift for metadata and Netty for data to a consolidated gRPC-based transport. gRPC provides quite a few nice abstractions around connections. One of them that we leverage is the idea of connection multiplexing. So before, if you had a client with multiple threads, they would each have their own connection to the Alluxio master, which was kind of a scaling bottleneck. With connection multiplexing, each client only has one connection, and they share that physical connection among all of the logical users within that client. Also, the gRPC threading model provides a way to scale the master without having to increase the number of threads on the master. So before, users would need to add like tens and hundreds of thousands of threads on the master, which ran into all sorts of different problems. And now with the gRPC transport, you can just use a fixed-sized thread pool. For the POSIX API, the way that we've been improving it and building it out is to basically take a workload, for example, TensorFlow's image recognition workload, and run quite a few stress tests against it, as well as functionality tests, and make sure we fully understand exactly how this application intends to use this POSIX API. And this leads to us improving our POSIX API and being able to say, for this specific framework, we are pretty confident that the API fully satisfies what it requires. And this is something that we're looking for more community feedback on in terms of which POSIX-based workloads to tackle next. For the job service, this is a new set of processes which kind of acts as Alluxio's personal computation framework. This lets us increase the replication by loading data from the understorage, or decrease the replication by removing data from Alluxio. We can also allow users to move data across different mount points, which previously they would just get an error saying this is not a metadata operation. So now the job service will actually handle the data portion of the operation. And also for async persist, the job service is able to do this automatically in the background. For the last feature of embedded journal and internal leader election, this feature really aims to remove the number of external dependencies Alluxio has. We found that a lot of users were saying they want to run a very lean and pure stack, such as Presto plus Alluxio plus S3, and they didn't want external dependencies such as HDFS or Zookeeper. So we have a new journaling service which is reliant only on the Alluxio master processes, and as a result, we're also able to leverage this for consensus. So we no longer need to use Zookeeper to elect a leader. So the last thing I wanted to talk about is our release roadmap. Currently, the 2.0 preview is already available, and I really encourage all of you guys to try out the preview release if you think any of the features I mentioned would be helpful to you, or if you're interested in those. And we've recently switched over from Jira to GitHub, so now it's pretty easy to just send a GitHub issue, and we'll try and triage that. And the Alluxio 2.0 GA release, which mostly will contain a lot of feature polishing as well as feature hardening, should be released in about 2 to 3 months. Okay, and that's it for the Alluxio 2.0 preview. If you guys have questions, you can send them over to Ali. And here are some resources that you might find useful if you want to learn more about Alluxio.
Great. Thank you, Calvin and Ben, for an awesome presentation on all the goodness of 2.0. So with that, just a reminder, if you do have a question, you can pop it into the questions box, and now is the time to ask the experts. So it looks like we do have a few that have come in. The first one, limitations on the embedded journal approach.
Yeah, so the embedded journal is a pretty new feature. In terms of limitations, from a performance perspective, it should be very similar to using distributed storage. One additional requirement for the embedded journal is the master nodes will need some disk-based storage. This previously wasn't the case, so now you would maybe need to provision a SSD or a reasonably sized hard disk. Something about 1 terabyte should be more than sufficient for over 1 billion files.
Great. Next question, is there an enterprise version or edition of 2.0? If so, how can I learn more about that?
Yeah, that's actually a good question. A lot of the information that I was talking about is in open source, and that's something you can get from the Alluxio org site. For the enterprise release, we are also planning to have a release at the same time the Alluxio 2.0 GA release is out for the open source. So definitely look forward to that, and it will have a lot more cool enterprise-focused features as well.
Cool, thanks, Calvin. Next question. Okay, it is not clear to me if Alluxio is an enterprise data management platform or a storage management system or some mix. How would you describe your offering?
So to me, I think Alluxio is a data orchestration system. So essentially, you want to have data stored physically in some reliable storage like S3 or HDFS. But it's not the job for this kind of storage system to really optimize the performance. Well, they can do to a certain degree, but it's getting harder and harder for them to really do the best job for different new emerging technologies, TensorFlow or all this new big data ecosystem frameworks, and especially adding the complexity from container orchestration, elastic computing. So it's just making the storage system doing too much together. So in my view, Alluxio is this as a new layer into this stack and trying to break the assumption. Basically, Alluxio assumes the data is persisted somewhere, and then let's just focus, do the job to orchestrate the data. So when data is needed, let's move it to where it is. And based on the access pattern, let's make decision how many replications to best facilitate the performance for the applications. So I won't describe Alluxio as a storage system. Instead, sometimes we describe this as a data access layer or some data abstraction. But essentially, the idea is to, on the compute side, build a new layer, a lightweight storage to help compute do a better job. and so the applications, developers, or data scientists can worry less about the physical data. That's my personal view. Calvin, do you have anything to add?
No, I think that's pretty accurate. Basically, Alluxio is a kind of a new thin layer between the compute and storage, and because it's not trying to solve the problem of persistence, it's able to have a lot more flexibility and control over kind of the logical placement of your data, as opposed to focusing on storing data efficiently.
Great, thank you both. Okay, next question. Will there be new features in 2.0 that are enterprise only?
Yeah, so the Enterprise 2.0 release is kind of in development, and we'll be sharing more information about that. But there definitely will be new features in 2.0 which are enterprise specific or targeted towards enterprise users.
Great, thank you. Next question. How performant is it to move data from a remote location to the cloud for processing? Think about hundreds of GB, maybe TBs.
Yeah, so in this case, when we talk about performance, you can think back to the 2 Sigma use case that been previously mentioned. When you need to move that data into the cloud for processing, generally there's a link between kind of your on-prem or wherever you had the data to your cloud nodes. And that link will kind of determine how long it's going to take to transfer that data. But the important thing about having Alluxio there is your data transfer is kind of a one-time thing, and then Alluxio will hold it in the cloud near the compute. This is basically the biggest problem that 2 Sigma was able to solve, because before, without Alluxio, they would need to transfer that data continuously, and for their machine learning workloads, they would iterate over the same data sets many, many times. So they would, if their data set was, let's say, 100 gigabytes, they might actually need to transfer 100 terabytes or something like that over the course of their simulation training.
Great, thanks, Calvin. Next question, I think, is for Ben. She can take. Can Alluxio be used to cluster local persistent storage?
So this is a great question. I do see users asking me questions like this, whether you can just use Alluxio as a persistent storage because you can just aggregate the local storage resource. So my view on this is that's not Alluxio is designed for, although maybe you can hack Alluxio around to do some functionalities. But essentially, I think if you have that view, then it's more like having Alluxio as a persistent storage. And in that case, I feel like HDFS is more designed for this purpose versus Alluxio is more designed for an ephemeral or a data access layer. So, for example, we have some concept is really just building for for example, the TTL or this concept of having data free, and they are just making sense in the case you have a real persistent layer. But if you have no persistent layer, but just using Alluxio aggregate the disk resource, I feel like it's very tricky to use a lot of semantics and API costs in Alluxio. Yeah, that's my answer.
Great, thank you, Ben. Okay, next question. For the web UI view, if current master node is dead, we should use new master node address for the web UI. Are you guys planning to solve this problem?
Yeah, this is actually a pretty common case that many users encounter when they're using HA mode. Some solutions I've seen is they put like load balancer in front of the master nodes, but this is something that we can also look into solving within Alluxio itself. Though we would still need the original master node that went down to come back up as a secondary in order to redirect it back to the currently serving primary. But if you have kind of ideas or ways that you think we should solve this problem, I really would encourage opening like a GitHub issue or something like that, and we can talk more about the technical implementations.
Great, thank you, Calvin. Okay, a few more questions here. What are the implications for upgrading to 2.0 from 1.x?
Yeah, so 2.0 is a major version upgrade. So what that means is there are some backward incompatible portions. But in terms of the state of the Alluxio system, so like your metadata and your journaling, all of that can be seamlessly transitioned from a 1.x release to a 2.0 release. What you would need to make sure is, let's say you're at Alluxio 1.8, is when you do the upgrade to 2.0, you let all of your downstream clients know that we're upgrading to 2.0 and give them the chance to update their clients to use Alluxio 2.0 clients.
Cool. How do you support 1 billion files? What are the pros and cons for this sort of approach?
Yeah, this is a great question. So I think Calvin mentioned a little bit in the slides. We originally, Alluxio 1.x, the bottleneck here to support many files or more files is because the memory we allocated to the server, to the master node, how much memory the JVM can sustain to make the master still functioning correctly, right? And we know for JVM-based JVM-based process, once you're using too much on-heap memory, the GC pressure is getting large, and the memory will, the process will just get into unstable states. So in order to solve this problem and support many more files, we do decide and we implement this by having a off-heap storage. Particularly, we leverage the RocksDB as an internal embedded key value service to serve the metadata. So in order to use this feature, you have to also allocate certain on-disk resource to Alluxio RocksDB, and in that way we can just have this served off-heap. And there's always pros and cons for different design choices. So in a naive implementation for using external storage like this, you will see a much better scalability to store many more files. But on the flip side is you may see a performance degradation when you retrieve data, because previously you served data on heap in Java, in the same Java process. Now you go across the RPC, not RPC, but the process boundary to go to the operating system file system call to retrieve the data, right? So we did a lot of engineering efforts to optimize this performance by having a working set of the inodes, the metadata, file system metadata cached also inside in Alluxio master process. And you can choose the size for this cache. So we hope this can mitigate most of the performance degradation or performance implication for having this scalability, extra scalability. But also we still provide the options that if you don't want to turn on this, you still can fall back to the original way to store your metadata on heap in Java, master Java process.
Great, thanks, Ben. Next question, we have a hybrid cloud environment. Where would Alluxio fit into this environment?
Yeah, so for the hybrid cloud deployment, the typical case, I'm not exactly sure about your setup, is users want to burst into the cloud, so leverage the kind of elastic cloud compute that they can use, but keep their data on-prem for security reasons, or just for the case that it's hard to move the data from on-prem into a cloud storage. So generally, people deploy Alluxio near the compute in the cloud. So either as a standalone Alluxio cluster in the cloud, or co-located with the compute that's being elastically scaled up and down.
Great. Okay, that looks like all the questions we received. So thanks a ton. Some good questions in there. So with that, I want to say thank you to both Ben and Calvin for the presentation today. We hope everybody that stuck around got a lot out of it. Just a reminder, we did record this session, so you will be receiving a link to that recording as well as the slides presented today. And on the slide that you see currently, you can see a list of all the different resources where you can go to find a lot of the things we talked about and or to interact with our community. With that, thank you all for attending. Thanks again to the presenters, and we will see you next time.